Good morning, everyone, and thank you for joining me today. I'm Dr. S.K. Singh, and I'm pleased to welcome you to this presentation on troubleshooting in GC analysis and remedial actions. Today, we'll explore common issues faced during gas chromatography, along with practical solutions to address them. Over the next few slides, I'll guide you through identifying problems and implementing effective remedies to improve your analytical results. Let's get started. Welcome to the introduction of gas chromatography, or GC, which is a fundamental technique used in analytical chemistry. It's widely employed for separating, identifying, and quantifying compounds that are volatile or semi-volatile. In a typical GC process, the sample is first vaporized in the injector. From there, an inert gas, such as helium, nitrogen, or hydrogen, acts as the carrier, pushing the vaporized sample through a long, narrow column. As the mixture moves through the column, each component interacts differently with the stationary phase inside. This causes separation based on properties like volatility and polarity. An important concept here is the retention time, the specific time it takes for each compound to exit the column, which helps us identify the compounds in a mixture. Once separated, these compounds are detected using various detectors, including flame ionization detectors, thermal conductivity detectors, and electron capture detectors. GC's versatility makes it invaluable across many fields: pharmaceuticals, environmental monitoring, petrochemical industries, food testing, and forensic science. Its main advantages are high sensitivity and resolution, rapid analysis times, excellent reproducibility, and the ability to handle complex mixtures efficiently. Overall, GC is a crucial tool in our analytical toolbox, enabling precise qualitative and quantitative analysis of gases and volatile substances, an essential part of advancing scientific understanding and ensuring quality in many industries. Let's take a look at some of the common GC problems you might encounter. First, no peaks can be frustrating because it suggests that your analytes are not being detected at all. Next, low sensitivity means your method isn't detecting the analytes at the required levels, which can lead to inaccurate results. Peak tailing or fronting can distort the shape of your peaks, making quantification difficult. Baseline noise or drift can obscure signals and reduce the precision of your measurements. Retention time shifts can cause issues with identifying compounds consistently. Ghost peaks are unexpected signals that can confuse your analysis, and column bleeding refers to the unwanted release of stationary phase components, which can interfere with your detection. Now, why is troubleshooting so important? Well, it ensures your results are accurate and reproducible, which is critical in any analytical work. It also prevents instrument downtime. When issues go unaddressed, your instrument may need more frequent repairs or maintenance. Troubleshooting helps extend the life of your columns and detectors, saving you money in the long run. And ultimately, it maintains your analytical efficiency, allowing you to deliver reliable, high-quality data consistently. So, understanding and addressing these common problems is key to maintaining a smooth and effective GC operation. Let's talk about the first common problem we might encounter, which is no peaks. This usually indicates that no signals are showing up in our analysis. The causes can vary, but some of the main ones include not injecting a sample at all, or the detector not functioning properly. Sometimes, issues with the carrier gas flow can also be to blame, or there could be problems with the injector itself. To address this, we want to start by checking our syringe and making sure we're using the correct injection technique. It's also important to verify that the detector settings are properly configured and functioning. Additionally, confirming that the gas supply is steady and the flow rate is correct can prevent many issues. Lastly, inspecting the injector temperature to ensure it's at the right level can make a big difference. By systematically going through these potential causes and remedies, we can troubleshoot effectively and get our peaks to appear as expected. This is a fundamental step in ensuring accurate and reliable results in our analysis. Let's talk about the second common problem: low sensitivity. This issue can really hinder our ability to detect and quantify analytes accurately. Now, some of the main causes include detector contamination, which can reduce the detector's responsiveness. Low sample concentration, meaning there simply isn't enough analyte in the sample to produce a strong signal, and poor injection technique, which can lead to inconsistent or insufficient sample introduction. To address these issues, we can start by cleaning the detector thoroughly to remove any contaminants that might be affecting its performance. Increasing the injection volume is another effective remedy, as it introduces more analyte into the system, boosting the signal. And finally, optimizing the injection parameters, such as injection speed and volume, can help us get the most consistent and sensitive results. By understanding these causes and remedies, we can improve our sensitivity and ensure more reliable analytical results across our work. Let's talk about problem 3, which is peak tailing. This issue can often be caused by several factors. For instance, active sites in the column or injector can lead to tailing because they cause interactions with the analytes, resulting in broadened peaks. Additionally, column contamination, perhaps from residues or impurities, can also contribute to this problem. Sometimes, the liner used in the injector isn't properly deactivated or is incompatible, which can further exacerbate peak tailing. Now, to address these causes, there are a few effective remedies. One approach is to replace or properly condition the column to restore its optimal performance. Using deactivated liners can also help minimize interactions that cause tailing. And finally, optimizing the temperature program can improve peak shape by ensuring better separation and reducing tailing effects. By understanding these causes and applying the appropriate remedies, we can significantly improve the quality of our chromatographic results and maintain the overall integrity of our analyses. All right, let's talk about problem 4, which is peak fronting. This is a common issue you might encounter in chromatography. The main causes of peak fronting are typically column overload and high sample concentration. When we overload the column, we push the sample beyond its capacity, which causes the peaks to front instead of being symmetrical. Similarly, if the sample concentration is too high, it can lead to the same problem because there's simply too much material being introduced at once. Now, to remedy this, we want to make some adjustments. First, diluting the sample is an effective way to reduce the amount of analyte being injected, helping to prevent overload. Second, reducing the injection volume also helps because less sample is introduced into the system at one time. By implementing these strategies, diluting your sample and decreasing your injection volume, you can improve peak shape and get more accurate, reliable results. Remember, these adjustments are essential for maintaining the integrity of your chromatography and ensuring your data is trustworthy. Let's talk about problem 5, which is baseline noise. This is a common issue that can affect the accuracy of our measurements. The causes of baseline noise can be varied, but some of the main ones include contaminated gases, detector instability, and electrical interference. Contaminated gases are a big factor. If the gases aren't pure, they can introduce unwanted signals that add noise to our baseline. Detector instability is another cause. If the detector isn't stable or properly calibrated, its output can fluctuate and create noise. Electrical interference is also a key contributor. External electrical sources can disrupt the detector's signals, leading to increased baseline noise. Now, to address these issues, we have some effective remedies. First, using high-purity gases is crucial because it reduces contamination and minimizes noise caused by impurities. Next, replacing gas filters regularly helps ensure the gases remain clean and free of contaminants. Lastly, stabilizing the detector, whether through proper calibration or environmental controls, can significantly reduce fluctuations and improve measurement stability. Overall, controlling baseline noise is essential for reliable data, and understanding these causes and remedies helps us maintain the accuracy and precision of our analysis. Let's talk about problem 6, which is baseline drift. This is a common issue in analytical instruments that can really affect the accuracy of our results. One of the main causes is column bleeding, where some components slowly leach out of the column, causing the baseline to shift. Temperature fluctuations are another big factor. If the oven temperature isn't stable, it can lead to inconsistent detector responses. And finally, detector contamination, which happens when debris or residues build up on the detector, can also cause baseline drift. To address these issues, we need to take some straightforward but important steps. First, it's crucial to condition the column properly before running samples, which helps stabilize the baseline. Maintaining a stable oven temperature is also key. Fluctuations can really throw things off, so keeping the temperature consistent helps ensure reliable results. And of course, regularly cleaning the detector prevents contamination from building up and causing drift. By understanding these causes and remedies, we can better maintain the integrity of our analyses and ensure our data remains accurate and reproducible. Let's talk about problem 7, which is retention time shift. This is a common issue in chromatography, and understanding the causes is key to resolving it. First, changes in flow rate can significantly affect retention times. Even small fluctuations can cause the analytes to elute earlier or later than expected. Next, temperature variation is another major factor. Since temperature influences the interactions between analytes and the column, inconsistent temperatures can lead to shifts. Lastly, column aging is inevitable over time. As columns age, their performance deteriorates, which also impacts retention times. To address these issues, we have some effective remedies. Calibrating the flow controller regularly helps ensure consistent flow rates. Maintaining a constant temperature during analysis minimizes variability. And of course, replacing the aged column when it no longer performs optimally is essential. By understanding and controlling these factors, we can maintain accurate and reliable retention times throughout our analyses. Now, let's move on to problem 8, which is ghost peaks. These are tricky because they can appear unexpectedly during analysis. The main causes for ghost peaks often involve sample carryover, which means remnants of previous samples are contaminating the current run. Another common cause is contaminated equipment, such as the injector or the column itself. If these components aren't properly cleaned or maintained, they can introduce unwanted signals that look like real peaks. To address this issue, there are several effective remedies. First, it's important to clean the injector and syringe thoroughly to remove any residual sample. Running blank injections is also a good practice. This helps flush out any lingering contaminants before analyzing your actual sample. Additionally, performing a bakeout of the column can help. Baking out involves heating the column to remove any trapped impurities, ensuring cleaner baseline and more accurate results. By understanding these causes and remedies, we can minimize ghost peaks and improve the reliability of our analytical data. This ties back into our overall theme of maintaining high quality and consistent chromatography performance. Let's talk about problem 9, which is column bleeding. This issue can often be traced back to a couple of main causes. One common cause is operating the oven at too high a temperature, which can put stress on the column. Another cause is the natural degradation of the column over time, which can lead to bleeding. So, what can we do to address this? The key is to operate within the recommended temperature limits to prevent overheating. If the column has degraded significantly, it's usually best to replace it to ensure proper functioning. By understanding these causes and remedies, we can better maintain our equipment and avoid costly downtime. This ties into our overall theme of proactive maintenance and process control to ensure quality and efficiency. Let's now talk about preventive maintenance, which is crucial for ensuring reliable and accurate results. First, using high-purity carrier gases is essential because impurities can affect our analysis, so always opt for the best quality gases available. Next, regularly replacing septa and liners helps prevent contamination and leaks. These small components wear out over time, but are vital for maintaining system integrity. Conditioning the column before use is another key step. It helps stabilize the system and improves performance right from the start. Routine system checks and calibration are also critical. Regular inspections catch issues early and keep our instruments running accurately. Lastly, maintaining a clean injection system cannot be overstated. Cleanliness minimizes contamination and ensures consistent sample introduction. When we implement these preventive measures consistently, It not only prolongs the lifespan of our equipment, but also guarantees the precision and reliability of our analytical results, which is at the heart of our overall quality control. Let's wrap up with some key takeaways. First, troubleshooting GC is absolutely essential if we want reliable results. When issues arise, quickly identifying the root causes helps us avoid wasting time and ensures accuracy. Next, focusing on preventive maintenance plays a big role in minimizing potential problems before they happen, saving us headaches down the line. And finally, proper handling of the equipment is crucial for its longevity. When we treat our instruments with care, they last longer and perform better, which ultimately supports the overall theme of maintaining high-quality, dependable analytical results. If you need any further support, please don't hesitate to reach out. We're here to help you succeed and ensure you have all the resources you need. Feel free to contact us with any questions or for additional assistance. Thank you so much for your time and attention today. We truly appreciate your commitment and engagement. Remember, we're always available to support you on your journey. Have a great day.